So what if I gave you a compound for Lewis dot structures? And I said, all right, let's draw the Lewis dot structure for water. Well, our first step is going to be counting all the valence electrons for each element in that compound. So starting with hydrogen, we need to look at how many valence electrons one atom of hydrogen has. And we know that hydrogen is in group 1, which means that it has 1 valence electron. But you see that we have a 2 there, so this is just like counting atoms. So we've got 2, so we're going to do 2 times 1. That means hydrogen has 2 valence electrons. But what about oxygen? Oxygen is in group 16, which means it has 6 valence electrons. Well, there's only 1 atom, so there's 6 oxygens. But now I need to add all of these together because I want to know how many valence electrons for this whole entire compound I have to work with. Well, 6 plus 2, I have 8 valence electrons for water. All right. The next step to drawing Lewis dot structures for a compound is going to be drawing the first atom in the center. Unless the first atom is hydrogen, then you draw the second. So if I gave you this, we would draw the carbon in the center. But I want to do water like we worked with in the first part of this, which hydrogen is first. So that means we're going to put oxygen in the middle. All right, that seems fairly easy enough. Now, we need to connect all the other atoms to the center atom with a single bond. What is a single bond? A single bond is something that allows the transfer of electrons between the different atoms in the compound. We talked about ionic bonding and covalent bonding, and this kind of symbolizes what they're doing. This shows that they're transferring electrons in a way. And each of these single bonds counts as 2 electrons instead of 1 like with the dot. Because typically when we have a bond, that means each atom is sharing 1 electron to each other. And typically we call these bonds shared pairs because electrons prefer to come in pairs, which is why we also draw them the way we do. So let's do water. We had oxygen in the center, H2O, so we have to connect 2 hydrogens. And typically you're going to make it look like that because just like with the electrons, all of your atoms want to be as far apart as possible. So finally, we need to complete the octet, which means we have to take any remaining electrons we have and put them around whatever needs to finish its octet. And we call these electrons lone pairs because everything prefers to be in a pair, but they're not being shared with any other elements. In this case, oxygen is going to have them all to itself. All right, so let's figure out how many electrons we have left to play with. As I told you, each bond counts as 2 electrons. So that means we have 2 electrons here and 2 electrons here. So that means we've already used 4. And I said that we had 8. Well, that means we have 4 yet to work with. Well, hydrogen has 2 electrons that it's playing with on both sides. And remember, hydrogen only needs 2. So you may be a little confused on why I'm saying that hydrogen has 2 and oxygen has 4 right now. Because if you look at this bond is connected to both oxygen and hydrogen. So they're sharing these. they both can use these electrons at any time. Hydrogen, this one right here, has these 2 electrons to play with, but oxygen also has them to play with, along with this hydrogen. So oxygen actually has 4 electrons that it can play with, whereas each hydrogen has 2. So now we've got 4 electrons that we have to put around the oxygen because the hydrogens have their octet filled. So we're going to make it look like this. Now oxygen has 8 electrons and hydrogen has 2 each. Alright, let's try an example. I've got CH2Cl2. Well, first we have to count up all of our valence electrons. Carbon, group 14, so carbon has 4. Hydrogen has 1 times 2, so that means hydrogen has 2. Chlorine has 7 because it's in group 17, so 7 times 2 is 14. So 4 plus 2 plus 4 is 20. That's how many electrons we have to have in our Lewis dot structure. All right, now take our first element and make it our center. So our first element is carbon. Let's make that our center. Next step, connecting all the other atoms to the center with a single bond. So we have 2 hydrogens, 2 chlorines. All right, so let's count how many electrons we've already used. We've got 2, 4, 6, 8. We've used 8, so that means we have 12 yet. Well, what atoms still need 8 electrons? Hydrogens, both of them have their 2. Carbon has 2, 4, 6, 8, so carbon's good. But chlorine has 2, and this chlorine has 2. Well, how do we complete their octets? Well, what's 8 minus 2? 8 minus 2 is 6. We have 2 different chlorine atoms that need to be filled. So let's give each chlorine atom 6 electrons because we have 12. So in this case, you can just kind of go like this, put all the lone pairs around. All right, everything's full. Great. Let's try CH4. First, count your valence electrons. We know carbon has 4, hydrogen has 1 times 4. That means it's 4, and we have 8 to play with. Carbon is going to be our central atom. Connect each one with a single bond. Well, we might be done. Let's count. There's 2 electrons to this bond, 2 here, 2 here, and 2 here. So it looks like our hydrogens are all good. And our carbon, we've got 2, 4, 6, 8. We're good. We've completed our octet and used all of our electrons.